This is an overview, review of factoring quadratics. We're going to go over 4 different kinds of factoring. This kind of lets you see them all at one time. You've probably already learned them, so this is just a refresher for these. The reason you learn factoring quadratics is you start trying to solve quadratic equations. The first thing you have to do is factor the quadratic part. Or you're trying to simplify rational expressions, the first thing you have to do is factor. So this gets to be pretty important, and it's a stumbling block for a lot of my kids. I know they think they knew how to factor, and then we start trying to do it as a part of a problem instead of just alone, and they stumble a little bit. So this will be a good, refresher course. Okay, I have this graphic. I'll put a link to it in the description, and this is what I'm going to be using for notes. So if you want to pause for a second and go print yourself one of those or pull it up so you can look at it. But this is what I'm going to be going by. Now you can see there's 4 columns. That's for each different type. Up at the top it says GCF always. When you get ready to factor, you must always take out a greatest common factor if it's there. There's not always one, but you need to always look for it. So look for it first and then go on. Now the next step in factoring is to count your terms. That's how you decide which one of these you're going to use. All you have to do is count your terms. You're going to have 2, 3, or 4. So for just a second, let's talk about what a term is. A term is a constant by itself, or a variable by itself, or a combination of those multiplied together. Now, for example, 2xy is a term. Okay, it's all by itself. If I do this, now I have 2 terms, okay, here and here. Now the difference is terms are joined together by addition and subtraction signs. If I had 2xy times 3y squared, this whole thing makes one big term, but each separate piece is a factor because it's multiplied together. If I have 2x plus y in parentheses and 3x plus y, now I have 2 factors. Okay, each set of parentheses is not a term because there's no addition sign. If I wanted to make them terms, bringing this out a little bit farther, now this whole thing would be a term, and this whole thing would be a term. Okay, so that's the difference between terms and factors. Terms either stand alone or they're added and subtracted to each other. Factors are multiplied by each other. So let's factor. The very first one that we're going to look at for a binomial, which is 2 terms, it's a formula, and it's called the difference of 2 squares. And the formula looks like this. Sometimes they use a's and b's, sometimes they use x's and y's. But you've got x plus y times x minus y. Alright, now let's look at how this applies to some numbers. And going down the chart, I've looked for a greatest common factor. There is nothing that goes into either one of these. And then I've counted my terms. I have 1, 2. That lets me know I'm in this first column. The only choice I have to factor is by using the difference of 2 squares. In order to use the difference of 2 squares, you have to have a minus sign, because that's what difference means. And then you have to have perfect squares both places here. Both terms have to be a perfect square. We do have that. So, to apply the formula, that's the easy part, you're going to take the square root of the first, which is x, plus the square root of the last, and the square root of the first minus the square root of the last. This would be factored form of x squared minus 25. If you want to check yourself, you can, on all of these, you are actually unfoiling. That's what factoring is. So you could foil this back together and get your original. So let's look at just a couple more examples. Here are three more examples, so let's just apply them. First, let's check this one. Is there a greatest common factor? No. Do I have a minus sign? Yes, I do. Do I have two perfect squares? Yes, I do. If you're fuzzy on what your perfect squares are, then you might want to make yourself a little cheat sheet off somewhere. Just make a list of all the perfect squares. That would be 1, 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, and however far down you want to go. But these are all your perfect squares. So, the square root of 4x to the second is 2x. I'm going to use plus, the square root of 81 is 9. And then I'll have that same thing with a minus sign in there. That is factored form of this. Now let's look at this one. Do I have a greatest common factor? No. Do I have a minus sign in the middle? No, I do not. But I do have two terms. They are perfect squares, but you have to have that minus sign. So right now, this is not possible, okay? We can't factor this right now. All right, let's look at this one. Do I have two perfect squares? Yes, 16. Anytime you have a variable raised to an even exponent, that's a perfect square. If I've got x to the 6th, x to the 8th, x to the 10th, that's a perfect square. So x to the 4th is a perfect square, 1 is a perfect square. So when I factor this, I'm going to get 4x to the 2nd. The square root of x to the 4th is x to the 2nd, because if I wanted to multiply them back together, you add those exponents. So plus 1 and 4x squared minus 1. Now, hold on, because we are not finished on this one. Check your factors. This factor still contains a difference of two squares. You're not in simplest form until all of your factors contain no more factors. This is fine. I can't factor this anymore because it has a plus sign. So I'm just going to write it down here because I don't want to lose it. Now I can factor this again using the difference of two squares. The square root of 4x squared is 2x plus 1, 2x minus 1. Okay? And that's all we have to do. Now let's go on to the next one. Okay, I have two separate problems up here. They look almost alike, but they're not quite alike. If you look on your chart, on your factor tree or your overview, whatever you want to call it, both of these in the middle say trinomial. So that means there's three terms. What's the difference? Well, on the left-hand side it says a is equal to 1 or a is greater than 1. These are the two differences. A in a quadratic is the coefficient of this leading term. The coefficient of this is actually 1, even though we don't use it. The coefficient of this is 2. So this is a problem that's going to fit in column 1, which is what we're fixing to look at. This is the kind of a problem we're going to look at in column 2. Just because this number is greater than 1, or because there is a number there. Okay, so I'm going to erase this. I just wanted you to see how to tell the difference. Alright, so we know we have to factor a quadratic. We know it's a quadratic because there's an exponent. So then you go through your analysis. First of all, is there a greatest common factor? No, so we're good to go. Count your terms. 1, 2, 3. And we've already decided that we're going to use the first kind of trinomial because there is nothing there. Now remember, when you get your final answer here, it's going to be in the form of binomial times binomial, because that's what you use to get this. You fold this together to get this. Okay? First of all, when you fold, you multiply this times this to get this number. So what would you multiply together times itself to get x squared? Well, that's going to be x and x. That was not hard at all. The next thing we need to do is decide what signs are going to go here and here. Now, when you have a trinomial, you have two signs. if this second sign is a minus sign, you're going to have one of each sign. So let me just do it up here. If this is a minus sign, you're going to have a plus or a minus in these two things, and it doesn't matter where you put it. Now, if you had a plus sign here, your two binomials are going to be whatever this sign is. So, let me get a little more organized. You would have a plus and a minus. If you have a plus and a plus, you've got a plus and a plus. If this is a minus, you're going to have a minus and a minus. And that made a really big mess. But this chart, that's on here. That's what this is right here. So you need to memorize that so you'll know what signs go in your two binomials. Okay, so since this is a minus sign, we are going to have a plus and a minus. Now the only thing we need to do is figure out which two signs are going to go here and here. I mean, which two numbers. So these two numbers have to share two characteristics. I have to be able to multiply them together to get this number. Then I have to be able to add them together to get this number. So first, let's pick out all the multiples of 10. We're going to make a little chart under 10, and we're going to get all the multiples, because that will give me all my choices, and then I can pick one from there. So when I multiply -1 times 10, 1 times -10. Now if this number is positive, if you have a plus sign here, you don't have to do both sets. You can just, assume that they're both positive or both negative. So -2, +5, +2, -5. Now which pair adds up or combines to give me -3? It's going to be this pair, correct? So these are the numbers that will go here and here. Now since the 2 is positive, put it where the plus sign is. Since the 5 is negative, put it there. And this is final form of factoring this quadratic. Once again, if you want to check it, use full, first, outside, inside, and last, and see if you get this original expression. For the next problem on your sheet, we're going to skip the third column. We're going to skip down here to the fourth one that says 4 terms. And you'll see why in just a second. We're going to circle back to the third one. So let's look at a 4-term polynomial. You counted your terms. You look to see if you have a greatest common factor. And you actually do. What will go into all of these is 3. So let's take 3 out of this first. That's going to be 6x squared plus 4xy minus 3xy minus 2y squared. Okay. Now, we're not going to lose the 3, but I'm just going to move it out here so I don't lose it. But I'm dealing with this right now. I've gotten out all of my greatest common factors. What we want to do is a method called factoring by grouping. And first thing we got to do is group things together, okay, with parentheses. Just put the first 2 items in parentheses and the second 2 terms in parentheses. Now, we're going to take out the greatest common factor between those two things again. The greatest common factor between 6x squared and 4xy is 2x. When I pull that out of each one of these terms, I get 3x plus 2y. Here's this minus sign. Now, what's in common right here is the y, and that's it. So when I factor out a y, I'm going to have 3x here. Now, this is where you have to be careful, because I'm actually factoring out a negative y or a minus y. If this is a minus sign, it's going to change this sign. It's going to make it the opposite of what it is. So when I factor out, this is going to change to a plus. Y into 2y squared leaves me 2y. Now, see, at this point, these two sets of parentheses match. They have to match right here. If they don't match, you did something wrong. So go back and check your math and see if you didn't get the greatest common factor out. Now that these two match, these become your next greatest common factor. So let's pull this out. I've got my 3 over here. I'm not losing it. Now I have 3x plus 2y. Just like with the other ones, you're going to wind up with 2 binomials multiplied together. So what's going to go right here is what's left over when you divided that out, which is 2x minus y. And that's how you factor by grouping. Whew, we're finally ready for the last grouping. And we're circling back to this third column now for factoring. So let's just get started. Let's analyze it. We see that we do have a quadratic because there's exponents. We look for a greatest common factor and there isn't one. So our next step is to determine how to factor it. Count your terms. 1, 2, 3. Now since there is a number here greater than 1, a leading coefficient, I can't use the method that I just did on the other trinomial. It doesn't work. We use something called trial and error, which takes forever. And if you're interested in that, I'm sure you can Google trial and error method of factoring and you can watch somebody spend a while doing that. So this method is a lot shorter. It's called the AC method. That's why I wrote that down there. Now what is A and C? Well, when you have standard form of a quadratic, your first term is AX plus BY plus C, or BX and C. So this number is going to be A, and this number is going to be your C. AC means multiply those two numbers together, and we get 30. Now, we're going to make a chart under the 30, and we're going to write down all the factors of 30. 1 times 30. Since this is positive, we don't have to do the positive negative thing. We can just write the straight factors. 2 and 15, 3 and 10, 4 won't go. 5 times 6 is 30. And then at this point it flips around and starts going back up so we can stop. Now, we want to pick the pair that adds up to give us this middle term. Now I know that sounds familiar to the last one, but that's where it stops being the same, okay? What we're going to do is we are going to manipulate this 3-term polynomial and we're fixing to turn it into a 4-term polynomial, and we're going to do that by splitting this term. So we're not going to do anything to the first term. We're going to rewrite this middle term as 3xy plus 10xy. The value is the same. It's just manipulated a little bit. And then I've got the 2y squared down there on the end. Now that you have a 4-term polynomial, you can use the factoring by grouping that we looked at previously. You can group these two together and these two together. Now let's take out a greatest common factor. The greatest common factor between these two numbers is 3x. When I divide that out, I'm going to have 5x plus y. Okay? Now here, the greatest common factor is 2y. When I divide that out, I'm going to have 5x plus y. Look at what happened again. Just like the other time, these two sets of parentheses match. They have to match. If they don't match at this point, go back and find out why they don't, because factoring by grouping won't work. So this becomes my first factor, 5x plus y. Now I've used it from here and here. And what's left is 3x plus 2y. And that, my friends, is factoring a trinomial with the AC method. Okay? So like I said, I will put a link to this down in the description. You can print that out if you want to. And you can drop me some questions down below. I'll try to get back to you when I can. But I hope this helped y'all. You've got to learn to factor. Please, please, please learn to factor. See y'all later. Bye.